Hello everybody, I am Dikshita along with my teammates Lasya and Srinidhi, currently pursuing BTech in IT department from Gogaraju Rangaraju Institute of Engineering and Technology. We are doing a project under the guidance of Pratibha Swaraj ma'am, who is assistant professor in IT department. I am very excited to share our mini project with you all, which is motorized smart roofing system using IoT. Usually, India is prone to various climatic changes like unusual rainfalls, global warming, etc. The impact of them is very high on people. People like farmers dry their crop in the sun before selling them in the market. When it rains suddenly, they can't protect their crop properly and hence it gets spoiled. Similarly, the rooftop restaurant owners have no idea what to do if it rains suddenly. The clothes which are kept for drying in the sun gets wet again. Thus, the fluctuations in the environment will lead to many problems. Our project will try to provide a solution for all the above problems. There are no proper existing systems for this project. Farmers generally use a waterproof polythene cover which is used for covering the area manually in the specific place. Meanwhile, if they are not present in the nearby places, it will be difficult for them to protect the crop. Rooftop restaurants owners must vacate their customers, which incurs a huge loss to the owners. So, we proposed a system where we use a rainfall sensor to detect the rain and roof is spread over the area with the help of the motors. The people can be relieved even if it rains. The methodology we adopted in our project is there is a rain sensor involved to detect the rain from the environment. If it returns true, signals are sent to the board, then board commands the motors to start rotating. Thus, the roof is spread over the area. Then, the message will be sent to the user via the application. Then, if the rain sensor returns false, the roof is spread or not is checked again. If the roof is spread already, the roof traces back to the original position. The requirements are Arduino IDE software, Google's Firebase Cloud, Cordular application, Wi-Fi enabled board, rainfall sensor, motors. Coming to the design part, this is the use case diagram. This shows the requirements of our project. This is a sequence diagram. This diagram shows the sequence of activities involved in our project. This is a data flow diagram. The diagram shows how the data is flown among the components in our project. This is a state activity diagram which shows about the states and the transition caused due to the actions performed in the project. This is the architecture diagram. This involves the implementation of the project. The rainfall sensor is used to detect the rain, which is in the form of analog input. The rain control module will convert the analog value to the digital value and sends it to the Wi-Fi enabled board. If it rains, the motor starts rotating on the command of the board, through which the roof is spread. After spreading, the rain sensor detects continuously for a delay time. Then, if it is raining continuously, the roof stays in the same place. But if the rain stops, the roof must trace back. So, the board commands the motors to run in the opposite direction so that the roof can trace back. All the above information will be stored in the cloud so that the mobile application can access. Coming to the coding part, we need to install all the required libraries initially, and we need to provide the Firebase credentials like Firebase host and Firebase authorization key to the code. Then we need to give the details of the Wi-Fi. We need to give the details of the Wi-Fi, and we need to create some variables which tells about the roof status and rain info. And we have to define a pin which we are going to use is rain sensor pin as 34. We need to declare all the functions which are to be used in the code. We are using Wi-Fi initialization function. Here we need to initialize the Wi-Fi by providing the proper SSID and proper password to it. As long as the connection is not established, it will print dots. Whenever the connection is established, it will show the IP address of the connected device. Then Firebase initialization method will initialize the Firebase if we provide the proper host and authorization key to it. Firebase write operation will perform write operation, that is nothing but giving the data to the cloud. These are the tags which are used as paths to provide the data to the cloud. This is we are using a flag variable to determine the status of the roof. F is equals to 0 says that the roof is in the initial position, that is, the roof is closed. We are setting the pin mode of the rain sensor pin as input because it is an analog type of input. We are using a value variable to detect the analog input from the rain sensor pin. And if the value is greater than or equal to 4000, which means there is no rain, so the serial monitor will show there is no rain, and the variables are updated with the same value, and we need to write those values onto the Firebase. And if the value is less than 4000, that means we detected a rain. There is a resistance value symbolizes the resistance value, which means if there is water on the sensor, the resistance value decreases. So if the value is less than 4000, there is a rain detected. Update the variables and write them onto the Firebase. Then we need to check if the status of the roof is closed or not. If the roof is open, we need to close the roof by running the motors for a certain delay time. Then we need to stop the motors after the motors run for certain time. We need to update the status of the roof to the one, that is, the roof has closed. We need to update the variables and write them onto the Firebase. After the rain has stopped, if the value of the F is 1, that is, if the roof is closed, we need to open the roof by running the motors in opposite direction for certain delay time, then stopping the motors. Update the variables and write them onto the Firebase. This is the Gizmo board, this is the motor, and this is the groove compatible rain sensor. This is the L298 driver which is used to run the motors. These are the jumper cables which are used for establishment of the connection.
This is the execution video of a project. This is the initial setup of the circuit in this project. First, we need to upload the code to the board via Arduino upload button. Initially, when there is no rain, the serial monitor shows that there is no rain detected, and Firebase also shows that there is no rain detected and the status of the roof is closed. And the same values are reflected when we connect to a Cordeler app via Companion. And whenever there is a rain detected, the serial monitor shows that there is rain detected and the motor starts rotating in a direction through which the roof is spread. The serial monitor shows the rain is detected and the roof is open. The same values are reflected in the Firebase as well as in the Cordeler application. And when the rain stops, the serial monitor shows that the rain has stopped and the roof is closed. The same values will be reflected in the Firebase and the Cordeler application, and the motor will start rotating in the reverse direction such that the roof can be traced back.
Our entire project is guided and supported by Pratibha Swaraj ma'am, who is assistant professor in IT department. We have done this project as a team of three: I, myself, Lasya, and Srinidhi. Thank you.